So let me see if I can find you guys another example here. I brought a book with me. Let's see here. Well, that looks interesting. We can do the limit as x goes to 0 of sine of x to the tangent x power. I have a bad feeling. Oh, phew. I was worried I was going to see it over here, the camera. You know, every so often I'll erase an example and realize I never panned over to it. No. All right, so what I say limit, so this will be it for today. X goes to 0 of sine of x to the tangent x power. All right, so we do what? We do the power lemma. Limit as x goes to 0 from the, no, excuse me, my bad. Power lemma, exponential of the limit as x goes to 0 from the right of tangent of x times the natural log of the sine of x. By the power lemma, right? And so we'll call this thing hashtag. And we'll go to it. By the way, what kind of indeterminate power was this? I never even said. What happens to sine and tangent as x goes to 0? They both go to 0. So this is type 0 to the 0, all right? It's an indeterminate power. All right, so the power lemma applies. Ooh. Well, this is type 0 times, what happens to log of sine? Well, sine goes to 0, right? It's a small positive thing. What's the natural log of a small positive thing? Well, it's got that vertical asymptote that drops down. It's minus infinity. So this is type 0 times infinity. So I need to do something to this before I can Lhopital it. I think I'm going to try bringing tangent. I almost never have any success with moving natural log from where it is. Like as a rule of thumb, I leave natural log wherever I find it. I can't remember a problem where like 1 over natural log was a helpful thing. So almost always pick on the other guy. In this case, it's tangent. What happens if you move tangent to 1 over tangent? We have another thing we could write for that, right? 1 over tangent, what's that equal to? That's cotangent, right? So I can do cotangent. Now we're in business because we've got the top going to infinity and the bottom's also going to infinity. As we talked about earlier, cotangent goes to infinity as x goes to 0 from the right. Now, so I can apply L'Hopital's rule. Infinity over infinity. What do I got? I've got cosine of x over sine of x from the numerator. So that's the derivative of natural log is 1 over sine times the derivative of sine, which is cosine. So I get cosine over sine from differentiating the numerator. What's the derivative of cotangent? Remember, we've worked it out, I believe, it was minus cosecant squared. Now, you say, I forgot how to do that. Well, great, let's figure it out. Cotangent of x, differentiate, how do we do it? ddx of, well, you got yourself a cosine over sine. Now, if you don't know the definition of cotangent, well, you're kind of up a creek, aren't you? So you got to know that. So cosine over sine, and then quotient rule. So that's minus sine x, minus cosine x, derivative of the bottom, which is cosine x again. But I lost something here. Minus. Oh, yeah, minus. And there's both minuses. Okay, it's fine. All is well. Divided by sine squared. So what you got minus 1 over sine squared, which is also known as minus cosecant squared x. So that's why I wrote cosecant squared minus cosecant squared here. Because the derivative of a cotangent is minus cosecant squared. There's the proof. Yeah, so even though I rewrote minus cosecant squared as, well, I rewrote minus 1 over sine squared as cosecant squared, it's probably in our best interest to just go back to sines and cosines here, because then we can kind of sort through what's going on. So we've got what? We've got cosine of x divided by, I'm bringing the sign downstairs, sine of x. And then what's this cosecant squared? Well, I'm going to put the minus up here, guys. This cosecant, remember, is 1 over sine squared x, right? So one more step here, well, maybe 2 more steps. That's the same as the limit as x goes to 0 of minus sine squared x cosine x divided by sine x, right? So you can cancel this sine x, right, with this 2. Does that make sense? See why we cancel sine x with the 2? Because sine squared x is sine times sine. So I'm canceling one pair of the sines. You just leave me with a residual sign. And then, so I've got minus the sine of 0 times the cosine of 0. And can I do that? Is that a legit step? It is legit because this is 0, well, minus 0 times 1, which is also known as 0. 0 is the hashtag here. So what's the answer? The limit as x goes to 0 from the right of sine of x to the tangent x is equal to e to the 0, which is 1. So there you go. I am sorry, all of my indeterminate power problems seem to be working out to 1, except for our exponential example. I will try to find some for your homework which are more interesting, but not too many. This is, I'll probably ask you to do like 2 or 3 of these at most. The rest of the next, like the next mission should be, we probably have 5 or 6 like the other kind of Lhopital problems, and maybe a couple optimization problems. I think I need to do those still. Any questions? All right. Well, have a good day. I almost ended class. I guess I'm a minute early, right? Yes. Okay.